present and what's coming up in NewSpace, what we've seen Thursday and Friday, but also what's going to be of the future. There's a vision that's going to be that we're going towards from what are our next destinations, how are we going to get there, what are we going to do when we get there, how do we make it possible to settle, how do we improve the science we have through NewSpace commercial industry, and what is the future once we get there, what's the promise that NewSpace holds. That's what today's focus will be on. What is our goals? To begin today, I'd like to introduce Dr. Dan Rasky, the director of the NASA Ames Space Portal. Dr. Rasky is the senior scientist at NASA and as I mentioned, the director of the Space Portal. He's the co-founder of it as well. The Space Portal has the goal of being a friendly front door to emerging and non-traditional space companies here at NASA Ames, focusing on, of course, making it more savvy, getting the connections between NASA and emerging space much stronger. So, without further ado, Dr. Dan Rasky.
Thank you, Dan, and welcome everyone to a Saturday morning here. It's nice to see all the true believers on a bright Saturday morning. And I'm, of course, particularly pleased to see Pete Warden has made time to be here. So I've got to be on my best behavior, so I'll try to do the best that I can. What I wanted to talk about is the next big thing. And I want to acknowledge several of my co-authors on this, Lynn Harper, Bruce Pittman, who many of you know, and also Mark Newfield. And what I want to do today, and particularly in the context of our current national situation, that there's shuttle program has ended, there's a certain amount of distress about a debt ceiling, is to try to put something on the table of a potential, I think, attractive future. Because it's times like this, it's easy to lose sight of what the future can hold. And I'm reminded that it was actually during the Civil War that the Transcontinental Railroad got put in place. So when you have times of turbulence, there's actually moments of opportunity. So I'm hoping we can speak to that. So the next big thing I want to talk about is a flexible path to Mars with commercial opportunity and public benefits along the way. And this is actually a direction that we've gotten from President Obama, the NASA authorization that came out in 2010. And I want to put in place what we see right now, kind of a joint flexible thinking group that came together, and we put some of our ideas on the table as to what we thought this flexible path to Mars might look like in the coming years. So I want to walk you through this. And this is how things stand today, okay, in 2011. We have a space station that is going to be with us to at least 2020, we hope. We have a significant launch capability, both traditional companies such as Boeing and Lockheed, as well as new space companies such as SpaceX. We have considerable launch capability. SpaceX also has their Dragon capsule, which you'll see this over here. And I'm pleased to say that Dragon is flying my heat shield. Elon made a very good choice on his heat shield material for Dragon, and so I'm very pleased to see where it's at. And but this is where things stand, and so what might the future hold? Well, there's one other piece that we need to put on the table, is that we have a few issues, and one of them has to do with hazardous orbital debris, and it's a problem that has been growing over the years. I mean, many of you, I'm sure, heard the news a few weeks ago when the space station had to safe the astronauts into the Soyuz capsules because of a near pass of some, I guess, Chinese debris. And so this is a problem that we need to deal with to kind of clear the way to move forward. And one possibility for helping us with orbital debris is the commercial space industry. And there's a number of commercial concepts that actually have come to light that may be able to solve this problem. I show one here, an electrodynamic tether that a certain individual who's sitting in the audience here has proposed. And a very interesting thing about this concept is that it actually uses the Earth's magnetic field to help provide propulsion to clear debris. And it's one possibility. There's others that have been put forward. But it's an opportunity for commercial entities to come in and help us with this important problem. So here's 2012, and you notice the debris is starting to fade. In not too distant future, we hope to see a number of the Google Lunar X Prize teams operating on the lunar surface. And the earliest that we've seen is 2013. The Google Lunar X Prize runs roughly right now to the end of 2015. But I think there's a very good chance in 2013 plus time frame, we'll see a number of entities operating on the moon, which I think is going to be quite exciting. So there we are at 2013. Okay, 2014, the NASA Commercial Crew Program plus the private activities by SpaceX and other companies, I think we're going to see in the 2014 timeframe commercial public transportation to and from space. And again, this is going to open, I think, a number of different options for activities in space, as well as people to make money off of sending people back and forth to space. So there we are at 2014. NASA is quite interested in ISRU demonstrations on the moon, in situ resource utilization, essentially making use of resources at hand. And there's a number of proposals getting serious consideration within NASA, looking at getting both propellant as well as usable materials from the moon. And we would love to see some of those demonstrations go forward, and we're hoping like in the 2015 timeframe. There's 2015. Excuse me. There's also, of course, Bigelow, and Bigelow is doing a lot of work with private space stations, and we believe that that will continue. He's quite committed. Maybe you've had a chance to see Bob Bigelow talk about his activities. He's quite committed in his endeavors. He has the deep pockets to push it forward, kind of similar to what Elon's been doing with SpaceX. And so we think that we'll see significant activity by the 2016 timeframe. And there's a number of benefits that can come from these stations and the type of in-space research they can do on microbiology and space biotech and so on, space nanotech, that we think will provide significant benefits on terra firma here. And also, again, provide a number of different commercial opportunities for entrepreneurial and other private industry. So there we are, 2016. Okay, 2016 plus. Lunar surface power beaming. There are a number of companies looking at this. We actually had some very good discussions with one organization called Laser Motive. They were the ones who actually won the Centennial Challenge for power beaming propulsion. And there are opportunities for using this laser power beaming to help provide essentially a power infrastructure for the lunar surface, which again, many of you know, one of the challenges working on the moon is surviving a lunar night where it gets down to minus 150 C and the sun doesn't come up for 2 weeks. And so having some way that you can provide a power infrastructure for people who want to work on the moon at different locations is an important part of actually enabling a number of different activities on the moon. So there we are with the laser power beaming. Depots. There has been considerable renewed interest at NASA in depots. I was part of a study actually that's going on right now looking at depot architectures in contrast to all rocket architectures. And we have found, once again, that there are considerable advantages when you start looking at depots. And real briefly, if you're looking at going to destinations beyond LEO, roughly 2/3 of the mass you need to carry is fuel. So if you can buy that fuel on orbit instead of having to carry it with you in a very large rocket, you can reduce the size of your rocket by roughly a factor of 3. And that means instead of 100 metric tons, you can get by with something on the order of 30 metric tons, which is much more an evolvable class vehicle compared to our existing capability with the Atlas V Heavy or the Delta IV Heavy. and significantly under the proposed Falcon Heavy lift capability of 53 metric tons. So there's a number of advantages with depots. It also would provide a new market for commercial space companies and existing space companies to sell fuel to a government depot on orbit. We had some very good discussions with ULA about a year ago, and they told us that virtually every Atlas V that is launching today is launching several thousand pounds light on payload. They have excess fuel once the third stage is away and the second stage is in orbit. In fact, we had one gentleman tell us that on one recent Atlas V flight, they were flying 10,000 pounds light. So you could have flown a Buick to space just because you could. And what they did is they had so much excess delta V once they had the payload away. They did a number of interesting things with the second stage. Took it to different orbits, spun it in different directions just because they had excess fuel to burn. Well, instead of playing games with a second stage, if you could actually motor that second stage over to a fuel depot and sell it to the government at a set price, well, that would be a nice way to add some profit onto that launch. So there are a number of enablers there. If you want to go to destinations beyond LEO. So there we are in 2017 with the depots. There's also some real advantage of having depots closer to the moon. And real briefly, if you're at L1, you're essentially the high ground from a potential well standpoint with regard to any location on the moon. And so if you have a depot at the Lagrange point, L1, you essentially can get global lunar access. So it provides a really important infrastructure element to be able to operate easily on the moon, both to get to the moon as well as returning home. So there we are in 2018. Excuse me. 2019. With the advancement in teleoperation and autonomous capabilities that we use every day over the skies of Iraq and Afghanistan, we believe that we'll see a number of opportunities to pursue teleoperated and autonomous activities on the moon in this time frame. And one thing that could be accomplished is put in place the infrastructure, habitats, landing sites, power, and so on, to allow human habitation. And so a little bit differently than how we did Apollo, instead of having the astronauts go up front and with a lot of risk involved, essentially let the robots lead the way, put in place the infrastructure, essentially have a guaranteed habitat and return home capability before you try to send people. And again, this is something with advanced teleoperations we believe is very doable. So there we are in 2019. And one thing about 2019, that happens to be the 50th anniversary of Apollo. And so I'm sure on that date, people will be asking the question, well, what have we done in the 50 years since Apollo? And so having some significant activity on the moon at that point in time, I think would be a fitting tribute to the accomplishments of Apollo. Then what do we do after that? Okay, well, we need to put in place human transportation between the Earth and the moon. And keep in mind, if we had roughly 2014, 2015 that we were doing commercial transport to low Earth orbit, that essentially gives you 5 additional years to put in place the transportation capability for both cislunar and eventually lunar surface. Obviously, for the lunar surface, then you have to have a landing and launch capability. It gives you 5 years to put those capabilities in place. So there we are at 2020. And then potentially 2022, if all the pieces are in place, you could look at returning humans to the moon. And nice thing about 2022, that's the 50th anniversary of the last man on the moon. So again, it would be a fitting tribute that 50 years since the last person on the moon that you returned to the moon. But then we want to go farther. And if we look at fuel depots in other locations, such as L2, and also have the development of in-situ resource utilizations. So now you can be looking at using lunar resources for fuel, for water, for life support, for things that you want to do beyond the moon. There could be considerable savings. And actually there have been some studies that have looked at that. Right now, there's significant uncertainties, I guess I would say, relative to the cost effectiveness of using lunar resources versus taking resources from the Earth. But assuming that you get economies of scale and also develop the capabilities as you would expect if you've operated on the lunar surface for roughly 10 years, I think there's a number of opportunities to have significant savings in the costs to get resources from the moon to go to places beyond. So there we are, 2024. And then we come to 2025, and here we are, potentially at the point of crewed voyages beyond the moon. And these can be to asteroids, to the moons of Mars. Once you have the infrastructure in place where you can operate on the moon as well as move beyond the moon, now the door is open to lots of different destinations, given the interest and the value of going to those destinations at the time. So there we are in 2025. And then 2030, potentially landing people on Mars. And again, that is one of the big goals that has been laid on NASA from President Obama. You'd return people to Mars. And I think in this build scheme that we've laid out, you'd be looking roughly at 2030 to do that. We know, for example, that Elon is quite interested in doing this. In fact, he's designed his whole Falcon 9 Dragon system, including the launch escape system, to actually act as a decelerator to potentially allow the Dragon capsule to decelerate and land on Mars. I mean, that was one of his intentions behind his design of his Falcon 9 and Falcon Heavy and his Dragon system. So we're looking potentially at 2030. Might it be possible to actually have people on Mars at that time? So here we are then at 2030. And one thing I wanted to point out in this is that you look at all the different activities that could be in place by 2030, and there's a whole range of different things that could be happening, a lot of exciting opportunity. And what I want to just point out is that right now, most of our attention is focused here on launch vehicles and the ISS. And that's understandable, but look at all the other things we could be involved with if we move forward, I think, in a sensible way. And then you can look at a couple different pathways that such a scenario I've just laid out to you provides. One is a human pathway. Right now we have the ISS, and that can provide essentially a duration capability. How do we have people living in space for long durations? But what we want to be able to do then is move from being able to have people in space for long durations in low Earth orbit, first with government capabilities and private capabilities, but eventually moving on to places like the moon and then points beyond and then on to Mars. There's also a transportation pathway. Okay, what is the transportation infrastructure that allows these activities? And again, it starts off with launch vehicles to get to low Earth orbit, and then capsules and other systems to get people back from orbit back to the surface. Fuel depots that provide important infrastructure for in-space operation, space tugs to take things from low Earth orbit to other locations, lunar landers and lunar lifters to take you to the lunar surface and off the lunar surface, and then to points beyond. The commercial partnerships pathway, and this is a very important part of this whole scenario. This is assuming that you have significant commercial partnerships along the way. This is not a government-only activity. This is the government working collaboratively with commercial space industry, similar to how we built our whole aviation industry, okay, that the government worked very collaboratively through the NACA with the aviation industry to build a whole new industry. And so there's a tremendous opportunity for commercial participation in this type of a scenario. And then this is, I think, exceedingly important, the near-term Earth benefits pathway, because there needs to be benefits back to the taxpayers, people footing the bill for this as you move along. And again, there's a number of ways that we believe benefits will return to Earth from these types of activities, from understanding aging to helping to solve some terrible illnesses like kidney failure, to coming up with new materials that can have a dramatic impact on energy usage, energy storage, and so on. There's a whole range of different challenges that we face right now on Earth that I believe activities such as these will help provide solutions for. So again, how things stand today, here's where we're at. How things could stand, say, in the 2022 timeframe. And the bottom line on this is 21st century jobs and careers. What will be the 21st century jobs and careers that people in this audience, younger folks in this audience, my 15-year-old son, will be pursuing in this time frame? And many of us who have been in the aerospace industry for some time will obviously be watching from the sidelines or from the world beyond in 2022. But it's important for people who are looking at their careers now, okay, where do they want to go, to have some idea of what can they shoot for. And I think space activities and the whole panoply of different possibilities out there could provide a very fertile ground for 21st century jobs and careers. And I think most important, as we look further out, what are the opportunities we have for a prosperous future as a nation? And I think that's a really an important question that we need to answer right now. And I'm a firm believer that with serious development and activity in space, we actually will lay the framework for a prosperous future for our country. So I'm very pleased to be part of helping to move this along, and very pleased to have very heartfelt people who come in on a Saturday morning to listen to these things to help make it happen. And with that, I'm happy to take any questions. So first, questions from the audience? Yes. You just want to run the microphone?
So looking into the future, when you start seeing people go to the moon and start settling there, do you have a prediction for how many nations are going to be settling on the moon around the same time period?
I think that this is going to be fundamentally an international endeavor, very similar, I think, to the International Space Station. And so if you want to have something as a benchmark, we have 16 countries involved with the International Space Station. So I guess I would say at least 16. And but likely more. I think that for a whole host of reasons, as the world gets more global, gets more connected, the fact that no one country has the resources to do all of what I showed there on their own, that this is going to be fundamentally a global endeavor. So I would imagine many nations will be involved.
I want to say thanks, Dan. That was a really good, the most fleshed out presentation of the future and economic opportunities that I've seen in a while. Yesterday we saw a really good talk from Hoyt Davidson on the commercial space industry and suggestions for what NASA can do to support that. So I'm going to ask, how are we going to make this happen? He had some suggestions like additional SBIR levels, extending centennial challenges, and so on and so forth. Has the space portal given thought to what NASA
Very
can
much,
do?
yeah, very much. I think the most important thing that NASA needs to do is rediscover the NACA. And if you take a look at the NACA, this was very much a success model for building an industry. Started in 1915 through 1958, built an entire industry which was exceedingly important both to national security as well as our economic prosperity. And there's the model, and I think that's still in our genes here at NASA Ames. Many of you may know that there were 4 NACA research centers. Ames was number 2, Langley was the first one, and we had Glenn and Dryden. But I think that one of the most important things is for NASA to rediscover that, how you work collaboratively with both traditional and emerging companies. Again, it's something that we've done here at NASA Ames through our whole history, in part because we were birthed as an NACA center. But it's something we need to discover more. There are still certain things that NASA is going to need to take the lead on. Okay, things that have no real commercial market or opportunity behind them. You know, the high frontier type activities. That's where NASA needs to have more of what we'll call the Apollo model, where you have essentially kind of a government-funded and directed activity. But for a lot of the things that actually I just showed here, I mean, it's going to be much more, in my opinion, of an NACA type approach that will really make it happen. David? Over here.
Yeah, Dan, I wonder if you had any thoughts about opportunities for reuse of hardware. You know, of course, we tend to throw everything away after a use, with a few exceptions like the orbiter and the SRBs. But
right.
It seems like, you know, there's always debate about, you know, tugs. Can you slow them down? Can you do anything? A deep space hab? Can you put it back in an orbit where you could service it and reuse it? Other places, maybe you could repurpose hardware after its first mission. Just what's your thoughts on that?
Most hardware, if it's used frequently enough, you can make an economic case for reuse. And there's actually a chapter in the Office of the Chief Technologist Technology Roadmaps on low-cost, reliable access to space, and we get directly at this reuse question. And it turns out that the major impediment to reuse is more economic than technical. What I mean by that, you have to have a reason to reuse something very many times before it pays for itself to be reusable. And take a look at anything we reuse in our lives, our automobiles, our airplanes. We use them, you know, hundreds and thousands of times. Most space hardware to date we use very infrequently. So if you're using something very infrequently, then it gets very hard for it to be economically viable to be reusable. But once you use something very, very frequently, now it becomes economically viable for it to be reusable, and then it's much easier to bring the technologies into play to make that happen. So I think that as this goes forward, as we use space more routinely, we're going to see more and more reusability of all the elements that go into it, including the launch systems and in-space systems and so on. But it really comes down to the usability. How often do we need to use this? And if we're using it infrequently, then I think it'll stay as it currently is. Anybody over on this side?
On the reusability, one essentially goes first for mass like propellants, but then reusing with very little modification, and then reusing by getting some simple structural elements from extraterrestrial materials, and it's a whole set of process. So there needs to be a roadmap for that too. So what scenarios in the time frame you're given are there for these types of progressive steps to making, you know, fairly complicated stuff by pulling elements from the moon, from the Earth, from reuse, et cetera?
Well, see, I'm a big believer in the free market. So I think that if we can bring in commercial enterprise and people see an opportunity to make a profit by providing services and capabilities that are needed, that you will see these things naturally come about. And I think, again, looking back at NACA, that's essentially the route. We did not have a grand roadmap for NACA. What we had was, I think, an important philosophy on how the government needed to work with private industry so that both benefited. And so I think it's much more about a philosophy of working together collaboratively, and then you take advantage of opportunities as they present themselves. And like I say, right now, one opportunity is fuel depots. I think that that's a huge opportunity both for NASA and for commercial enterprise to do that and to significantly improve our capabilities to do things in space, and at the same time provide avenues for people to make money at providing that service. I've got a couple written questions here. Before we run out of time, let me just see if I can get to them. Do we still have the Project M in place to put R2 on the moon within 1,000 days? I'll ask one of my JSC colleagues, Dave, do you want to speak to that? I'm not sure what the official status is on M2, I'll be honest with you. I know about it, or Project M. I think it had a lot of interesting prospects. I don't know what the official status is on Project M. I'm sorry? I think that's right. Steve Altimus, I believe, was leading that out of JSC, and I think he got a cease and desist order on it, but I'm not sure. Okay, let me get the next one. NASA and its employees are old. So true. Actually, funny story, real briefly. The day I got promoted to be a senior scientist, my 13-year-old daughter looked at me and said, "Dad, that just means you're old." And so, it's true. Okay, what paradigm shift do you anticipate with the younger generation taking the more leadership positions in the administrations? Very good question. Again, my touchstone on this is my 15-year-old son, okay? And the big paradigm shift that I see from that generation is massive participation. They want to do it, okay? They don't want to watch someone else do this, okay? They want to be involved themselves. And they're used to that. They're used to the world they live in is a massive participation world. And so it's how can they be part of the design, part of the operations, part of the experiments. I think that's one of the biggest paradigm shifts that we're going to see coming through in space. And I'm hoping that the administration backs that as well. And are we about out of time here, Dan? Any more questions? Okay, well, thank you very much for your time.